Okay, so once we've got the rollers and everything tensioned to drive correctly, we then need to move on to the liner size and type of liner. As you can see, there's different types of liners for different rolls. We have gooseneck extensions. Every liner is appropriate for the wire being used, the diameter being used. So we'll start with this liner here, which is a carbon liner. So this is mainly used for silicon, bronze or aluminium. It's a carbon liner because it allows it to slide through nice and gently with the wire being so soft with silicon, bronze and aluminium. We have a gooseneck on the end of that wire that must touch the contact tip. If this liner was to run all the way to the contact tip, you would find it would start melting the end of the liner. So this is for heat protection and contact protection. You'll notice the handpieces are always curved, which makes the gooseneck curved so the wire runs on a contact through there the whole time. So that's a carbon liner. This is a Teflon liner. Again, silicon, bronze and aluminium. Nice and smooth for the wire to run through with no grabbing. Should really have a gooseneck attached to that too, because the Teflon will start melting with the heat that's generated, especially with silicon, bronze in the contact tip. So they're all put in, cut to length. They have the little locator here to tighten up. And then we go on to the stainless liner. So that's a one-piece liner. You'll notice the plastic cover, which is on here, has been removed so it doesn't overheat and melt the actual coating. So this stainless liner is designed for your normal steel welding. If you ran silicon, bronze or aluminium through this, it would actually file the wire down and get full of filings very, very quickly, because your stainless is a lot harder than those materials. And the gooseneck, flexible gooseneck, adjustable, cut it to length, replaceable for when they get bent on the ends like this or overheated on the ends. You can just replace that part. Very, very important part if you're doing aluminium or silicon, bronze, to make sure that you are getting a contact onto the wire. Okay, so with the liner also, the liners come out 0.6, 0.8. So if you're running a 0.6 wire that we should be in our industry, you would want the 0.6, 0.8 liner. If you run a 1mm liner or a 1.2, the wire, when it comes through the liner, will actually clump as it goes through. So when you pull the trigger at this end, the drive rollers start turning, which clumps the wire, and all of a sudden you get inconsistent wire feed out the other end. So if you have had a welder delivered to you for use and it has a 1mm liner in, you need to change that liner to a 0.6, 0.8 so you get a constant feed out the other end. With these ones, especially the stainless liners, how it files the wire as it goes through, you get the wear. These liners can get clogged up with filing, so every now and again you should be putting an air duster into one end and clearing the dust out of it. We've only got little drive roller motors pushing wire through 2 or 3 meters of cable. If that gets clogged up with dust, it will form resistance on your rollers, so you won't get consistent feed. So just remember, liner, so critical. The liner's laying on the ground in the handpiece, things get dropped on them, stood on. So if you get a kink in the liner, all of a sudden you have that to run through. So that's going to push resistance on the actual drive rollers and cause you a lot of problems. Because this is hidden inside this black cable, you can't tell if that has actually happened to your liner. So it's important to maintain your liner in good condition.